Hi everyone and welcome to the videos on stationary points. In this exercise I'm going to be talking about how we can actually find the stationary points, and there's basically one sort of key element to that. Basically it is that the derivative has to equal 0 at any stationary points, and I can show you really quickly why that is. So the types of stationary points that we're going to be looking for are local maximums, local minimums, and also points of inflection. So the thing is that all of these types of points, they all have a gradient of 0. They're all perfectly flat for that instant. And so anyway, that's what we're going to be doing. So in this question here, the displacement of a particle is given by x equals 2t minus 1/4 t cubed, where x is the distance in meters from its origin and t is the time in seconds. Find the maximum displacement. So to do a question like this, you could graph it. It's probably not a bad idea to do something like that, but for the purpose of this, I'm not going to worry about it at this point in time. I'm just going to straight away calculate dx dt. And that's just going to be 2 minus 3/4 of t squared. So what I can do now is I can then force this to equal 0. So when dx dt equals 0, we get 0 equals 2 minus 3/4 of t squared, which we can then add 3/4 of t squared onto both sides. So 3/4 of t squared equals 2. And I'm just going to continue this up here. So then we'll multiply everything by 4. So 3t squared equals 8. Divide everything by 3. So t squared equals 8/3. And then take the square root of both sides. So t equals plus or minus the square root of 8/3. So that's the times at which this happens. A couple of things I'm going to consider here is the shape of this graph here. Now this is a negative cubic, so because it's negative cubic it's going to be coming down like this. It has two stationary points, so I know that's going to be the shape of it. And basically we know that the first value, which in this case would be the negative square root of 8/3, is going to be the minimum here. We know that the second value, the positive square root of 8/3, is going to be the maximum right here. And we're looking for that maximum, so all that I need to do now is actually find out what the displacement is. So when t equals the square root of 8/3, I can sub that into my original equation to get the displacement. So x equals 2 times the square root of 8/3 minus 1/4 times the square root of 8/3 all cubed, which isn't a particularly nice answer. We could make it look a little bit nicer, so I'm going to write this as, well, I'll still leave that part as 2 root 8/3. Then we're going to have minus, now we've got the quarter at the front still. I can square this here pretty easily. So it's going to leave 8/3. And then I've still got one more of these left to be multiplied. And so that's still going to be square root of 8/3. Which in the end is 2 root 8/3. And then minus, now the 4 and the 8 will cancel out there, just leaving a 2 there and a 1 there. So that whole part there's just 1. So we've got 2/3 of root 8/3. Okay, and which we can even make a little bit nicer now.